Let's solve Unit 6 Software Engineering questions. In software configuration management, what is the primary purpose of version control? What is actually version control? This combines procedures and tools to manage different versions of configuration objects that are created during the software process. Configuration management allows the user to specify alternate configurations of the software system through the selection of appropriate versions. Say for example, if I have some 3 versions of code and I want to revert back to some other old version, this version control will help me to move to whichever version I want. So that is the purpose of version control. We'll just go through the options. To control the changes made to software, to document user requirements, to estimate project cost and to design the software architecture. This has nothing to do with 3 and 4. And it is nothing about user requirements also. So it is to control the changes made to software. You can just apply this to code versioning itself. So you will have a set of code as version 1, then you might have made some changes that becomes version 2, and you could have introduced some other features, so that would be version 3. So every time when you introduce some changes or when you make some other updates, that becomes a new version. I am telling you in the aspect of code alone. So if that code, if it has so many different versions, you have to just take code and replace any object that has been created during the software process. So that's why they have mentioned it as configuration objects. So to control the changes made to the software will be the primary purpose of version control. Option number 1 will be the right answer. Next question. If a software project has 2000 lines of code LOC, and the average productivity rate is 10 LOC per person hour, how many person hours are required to complete the project? So we will first understand what is actually this person hour. The work or the effort is actually mentioned in person hours unit. These many persons are required to work for these many hours in order to complete this particular task. The development effort in terms of person hours will be equal to size of the code divided by average productivity rate. That is, the LOC part is given in the numerator and the LOC per person hour is given in the denominator. The LOC is given as 2000 lines of code. So this is 2000 LOC divided by the average productivity rate is 10 LOC per person hour. So we can cancel 0 and 0 here. This is 200 and this LOC will get cancelled and this person hour will come to the numerator. So it takes 200 person hours to complete the project. Option number 3, 200 will be the right answer. This is going to be just 2000 divided by 10, but I am just explaining you with the units so that to tell you how person hours come for this particular question. Next question. Given a project that uses the COCOMO model with an estimated effort of 2000 person months and a productivity rate of 5 person month per KLOC, what is the estimated size of the project in KLOC? Now let's understand what is this person month. It is considered to be an appropriate unit for measuring effort because developers are typically assigned to a project for a certain number of months. So one person working for these many months or the number of persons working together for these many months. Now we have to find the estimated size of the project. This will be given by the estimated effort that has been given here divided by the productivity rate that is given here. Now we will just substitute the values. What is the estimated effort? It is 2000 person months divided by what is the productivity rate? It is 5 person months per KLOC. So you can cancel these two units. This KLOC will go to the numerator. This is 5 fours are, so totally you will have 400. 400 KLOC will be the right answer. Option number 2 will be the right answer. This is the estimated size of the project in KLOC. Next question. Given a project with an estimated effort of 1500 person hours and a team of 5 people, how many days will it take to complete the project if each person works 8 hours a day? Total work hours per day has to be found out first. Actually, if one person works for 8 hours, how many hours do 5 persons work? It is actually 5 into 8. Team size 5 into work hours of each person a day is 8 hours per day. So every day they have to work for 40 hours. Total work hours per day is equal to 40. Now they have asked the number of days to complete the project. Estimated effort of person hours divided by total work hours per day will give you the answer. What is the estimated effort? It is 1500. So 1500 person hours divided by what is the total work hours? Here it is 40 hours. So we can say person and hours together. So this is in terms of people and this is in terms of hours. So this can be taken as person hours per day. So here this two get cancelled. We will have 150 divided by 4. 4 threes are 12. We have 30. 4 sevens are 28. Then we have 2. We'll introduce a decimal point here. This is 4 5s are 20. We can have 37.5 days to complete the project. So this day will go to the numerator. So this is how we are bringing it to days unit here. 37.5 is available in option number 2. Option number 2 will be the right answer. Next question. Arrange the following phases of the agile process in the correct sequence. So what is actually agile software engineering? This represents a reasonable alternative to conventional software engineering for certain classes of software and certain types of software projects. Before agile process came into software engineering, we were using something called the waterfall model. So we have to go with requirement analysis, then we'll go for design phase, then we'll go for coding phase, then deployment, then maintenance. There will be a set of phases that will be followed in a particular order. But after this agile process came inside, based on the type of project or based on the type of software you are going to create, some changes were introduced in the life cycle of the software. They are asking for the general phases of the agile process. So it is not going to be too different from the traditional one. Any process will be starting with planning only. There are only two options starting with planning. So we will rule out the other two. It starts with E. After planning, definitely we will go for design. EA. After design, we will go for development. It is D. From this itself, we can rule out option number 4. After developing something, you need to test them. So once you test them, automatically you go for release of the particular product. So this will be the final step. EADCB. Option number 3 will be the right answer. Whether it is agile process or something, you know, a software development process will undergo all these phases. Generally, you have to know which phase will come first and which phase will come next. Even if you have that basic idea, you will be able to answer this question. Next question. Arrange the following steps of feature drive development process in the correct sequence. So they have given 5 options. I'll just give you the process in the sequence. So we are developing an overall model. This is A. The next step is to build a features list. So we have to build a list first, and only from that particular list we are going to plan by feature. So next step comes plan by feature, which is C. After planning, we are going to design by feature, that is going to be D. The next step is to build by feature, which is B. A, E, C, D, B. Option number 2 will be the right answer. So generally we have to develop an overall model first. After that we have to give a list of features. From that feature we have to pick one, plan for it, design it and then build it. So only with the help of features list you will be able to go with a particular feature. If you at least find these two phases correctly, you can answer this question. Next question. Which of the following are typical activities in the software process life cycle? So in software process life cycle, we have requirement analysis, then we have design, then we have development, then we have testing, then we have deployment, then maintenance. Now we have to pick only the activities that belong to software process cycle. Does every software process life cycle have requirement analysis? Yes. What about system design? Yes, design is also a part. What about code refactoring? It is not. What about deployment? Yes, it is there. And what about substructure? It is not there. So the typical activities will usually go for requirement analysis, then you go for design, then you go for development, testing, and then we go for deployment and maintenance. So we don't have code refactoring and substructure in this sequence. Option number 3, A, B and D only will be the right answer. Now we'll just see what are code factoring and substructure. Code factoring is the process of restructuring existing source code without changing its external behavior. The behavior of the code should not change, but you can make changes to the code. What about substructure? This is a view containing a selection of elements, thus providing the potential for simplified modeling within large models. So if you take this to be a view and some elements involved it, this is going to be a substructure. I'm just giving you a plain idea about what is substructure. Next question, which of the following are agile process models? So we know waterfall is actually existing from long time, and we know spiral is also existing before agile. Similarly, incremental model is also existing from before. If you have idea about this, you can easily narrow this list to A, extreme programming, and C, Scrum. So I'll give you a list of process models under agile software engineering. We have extreme programming, we have adaptive software development, we have Scrum, we have dynamic systems development method, we have Crystal, we have feature drive development, lean software development, agile modeling, and agile unified process. Now why have I actually highlighted few models is these models are available in latest editions. The rest of the models belong to some old editions. So the option that involves A and C will be option number 1. Option number 1 will be the right answer. So let's have a look about XP and Scrum now. Extreme programming's process cycle will be like this: planning, design, coding and testing. In coding we have something called refactoring, and if you take planning, it is done through user stories. Then design is done through CRC cards, and coding involves pair programming. Testing involves unit and acceptance testing. Then there comes the release after testing. So it's just a software increment, not the complete product. So every time it just goes on iterating and then giving an increment of the particular product. So this is extreme programming. What about Scrum? So they will be having a particular set of activities to be completed within a specific time. If you don't complete them, that will be taken to the next set of activities. Just for example, I am telling you, take week 1, you have to complete 10 activities. Week 2, you have to complete 7 activities. In case if you have 2 pending here, this 2 will be brought to this week. So it makes totally 9 activities that has to be completed. Similar process only will be happening. I am not explaining the exact technical scenario of Scrum. I am just telling you how this particular process model works. Next question, match list 1 with list 2. Software design principles are given in list 1 and definitions are given in list 2. We have cohesion, coupling, abstraction and modularity in list 1. What are cohesion and coupling? Cohesion is an indication of relative functional strength of a module. Within a module, how far they are relatedly strong. What is coupling? It's an indication of the relative interdependence among modules. So when there are 2 or 3 modules, how they are interdependent on each other. So this is within a module and this is between modules. Now just find the appropriate definition. Degree to which one module relies on another module. So here 2 modules are involved. So we can map this to coupling. B to 1. It is available only in one option. What about cohesion then? Degree to which elements of a module belong together. It is just based on a single module. So we can map A to 3. A3 and B1. So other options can be ruled out. Option number 3 will be the right answer. Now let's check for abstraction and modularity. Dividing a software system into distinct modules is what we call as modularity. So they will say working with different modules. So we can map D to 2. D2 is here. What about abstraction? It is simplifying complex reality by modeling classes appropriate to the problem. Abstraction is giving something in general. It is not specific, we can say. It is more about the generalization. Instead of going into deep, we are just giving a generalized idea of something. So this is what they have meant as simplifying complex reality by modeling classes appropriate to the problem. It is not specific to the problem, but that is just appropriate to the problem. A generalization kind of view, we can say. There are many levels of abstraction in software engineering. We are not getting into that topic. So we can map C to 4. C4 is also there. Next question. Match list 1 with list 2. List 1 has the testing types and list 2 has descriptions. We have unit testing, integration testing, system testing and acceptance testing. Unit testing focuses on each component individually, ensuring that it functions properly as a unit. So here testing individual components of the software exactly matches the statement here. So A will be mapping to 1. It is directly given. A1 is available in all the options. What about integration testing? This addresses the issues associated with the dual problems of verification and program construction. So here testing the interaction between integrated components. So testing something individually is unit testing. When you test integrated components, it becomes integration testing. The meaning is actually directly given. So B is mapping to 2. A1, B2 is available in 2 of the options. The rest 2 can be ruled out. What about system testing? It verifies that all the elements mesh properly and overall system function or performance is achieved. What about acceptance testing? It is conducted by the customer in an effort to exercise all required features and functions. So here, what is system testing? Testing the complete system to ensure it meets requirements. So whether it is able to function correctly, whether the performance is perfect, everything can be tested in system testing. We can map C to 4. 1 is also ruled out. What about acceptance testing? It is done by the customer. What does actually customer test? The customer will test whether it is meeting all the business needs. So in that aspect, D will be mapping to 3. Option number 2 will be the right answer. With this, we are completing Unit 6 solutions.